medium sebab nak susah tekan. Saya pilih medium, okay.
Okay, thank you. Okay, so recording have already started over here. So let's look at the subtopic phase diagram, yeah? You got your notes ready with you?
Yes, madam. Well, it's a bit messy because my previous notes were caught on fire accidentally.
Caught on fire. Tak
Well,
suka sangat
it's a long story, but don't worry, I've recovered most of them.
But you can the note is already in the Google Drive or Madam Personal My Link. You can always download the notes from there. It's just that you need to re-copy or rewrite some of the notes of it. Okay. Right. So Madam tukar sikit hari ni. I'm using another stylus pen. So let's see how it works. Okay, so chapter 5.4, the learning outcomes. Let's look at this one. We have to define the meaning of phase, triple point. Hold on a second, it doesn't work. Okay, so definitions of the phase, triple point, critical point. Okay, we need to identify on the phase diagram. You have to know how to sketch the phase diagram as well. But in the phase diagrams, you need to identify which point is the triple point, which point is our critical point. Okay, and then you need to be able to sketch the phase diagram for water and also carbon dioxide. Okay, and then after that, we want to compare the phase diagram. I'll say, what is the difference between the phase diagram for water and also the phase diagram for carbon dioxide, and explain the anomalous behavior of H2O. So comes again, that anomalous, it says a special or different or something, a abnormal behavior of the H2O. Okay, and then last one, the learning outcome over here is to describe the changes in phase with respect to temperature. Okay, temperature at constant pressure, isobaric, with respect to pressure at constant temperature, and another name over here is isothermal. So we will look further into it, what it means. Okay, so first of all, the term phase. The term phase over here, it means or it refers to homogeneous part of a system in contact with other parts of the system, but separated well by a well-defined boundary. So here is the keywords for a phase. Okay, awak akan nampak satu boundary yang sangat clear. So if let's say I only got a cup of water, let's say I got a cup of warm water, I only got one phase, which is liquid. So in this case, you need to identify the phase. It means that over here, maybe you have a liquid phase, you have a solid phase, or you have a gas phase. Okay, but when you say is separated by a well-defined boundary, so let's look at this example here. This is your first example, yeah? Okay, so in this one, what do you see? In this diagram, what do you see? First diagram here. This diagram doesn't have in your notes, but I just give some extra notes for you.
Ice.
Okay, you can see ice. What else you can see?
Ice water.
Ice with water. So how many phase can you see inside this glass?
3.
How many phase are there?
3.
Is it 3 phase? Water is what phase?
Liquid.
Liquid. Yang lain boleh jawab juga ya. Okay, how about the ice? What is the phase for an ice?
Solid.
Okay, solid. Dah aja seorang je ke yang lain? Okay, so there is only how many phase?
Kalau dia punya water vapor tu tak kira gas
What do you see water vapor? If let's say I close, kalau let's say cawan ni madam tutup, Kalau dia tutup, okay. Over here you have the water vapor. But then this is an open glass. Tak ada. Tak ada yang madam lukis tutup cover ni. So that means over here we only have
2.
two face. Okay. Kejap ya. Apa yang berlaku? Wait me for a moment ya. Okay, it jammed for a while. Okay, how about the second diagram? What do you see inside the glass? How many face would you see?
2. 1. 1.
Only one state only.
Only one face. Okay, only one face because you only got liquid phase. Okay, but then you have two components over here. You have two substance. We have a layer of oil and we have a layer of water. Okay, but in this case, we only got one phase but two component. Okay, I don't think I don't need to change back the stylus pen. Now you give me a second over here. All right. Okay, we go back to this one. All right, so madam, go back to the diagrams over here where we have the liquid phase over here. Both of these are liquid phase, but we have two substance. We have a layer of oil and then we have a layer of liquid. Okay, so all of this it can actually represent by a phase diagram. Okay, so a phase diagram, it refers to the diagram which show you the region, okay, of pressure and temperature at which one substance, okay, can exist as a solid, liquid, or vapor phase or thermodynamically stable. Okay, so inside this diagram, you can actually find the temperature and pressure for different phase of the substance. Okay, so vapor can also say as a gas phase lah. So depends whether you want to write as vapor or you want to write as gas phase. Okay, so if you look at your notes over here, we have an example of the phase diagram. So you can see over here we have our y-axis, which is the pressure. Okay, depends what is the unit is given now. So we have the y-axis as pressure against the x-axis temperature. Okay, so temperature over here, you have the unit of degrees Celsius. So this is your phase diagram. One of the examples lah. Okay, phase diagram. And then in this phase diagram, there's two very important points over here. One of it, we say it is a triple point. So please recognize the definitions of triple point. So triple point refers to when you have solid, liquid, and vapor that exist simultaneously in equilibrium. So please highlight also the words exist simultaneously. Or maybe you can write as exist at the same time. Okay, so at the same time, you can find three of these phases, solid, liquid, and vapor. Or maybe there is a words over here, you can write out also. Solid, liquid, and vapor coexist in equilibrium. So the meaning of coexist is the same as simultaneously, is the same as it appear at the same time. Okay, so triple point. The name is also, you recognize three of the phases. Okay, so the next one we have over here is the critical point. Okay, so if you look at the phase diagram here, if let's say we want to find triple point, which is the point? A, O, B, or C? If let's say over here is a phase diagram, right? So you can clearly see we have a solid phase. Okay, we have a liquid phase and we have a gas phase. So which is the point that represent the point, the triple point? Try to guess.
I reckon is O.
Oh, 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 oh.
You rasa O eh? Siapa lagi?
Rasa
Ada
lah.
jawapan lain tak? Rasa lah. So try to identify first before Madam explain more. So which one is your
Well,
triple point?
because after O,
Mm-hmm.
there's two lines. One
Mm-hmm.
is becoming linear, which for solid. Another one
Mm-hmm.
here, it becomes curve, quadratic curve,
Okay.
a bit like that.
And we won't use linear or quadratic curve over here lah, but then just to explain further what is the phase, if you can see over here, if for this curve, okay, from point A to point O, it's actually separate both of the phase of solid and gas. Gas also can reckon as vapor, yeah. All right, so AO will separate your solid phase and also gas phase. OB, this line OB, okay, separate the phase between solid and liquid. And then OC, separate the phase between OC, separate which phase?
Liquid and gas.
Liquid and gas. So again, we're back to triple point. So which point, A, O, B, or C, which one you will find three phases at the same time?
C.
Oh,
Rasanya mana satu point yang awak rasa dia duduk tengah-tengah antara ketiga-tiga phase?
oh,
Alright, this is very clear that this point O is actually your triple point, whereby you can find solid, liquid, and gas at the same time. So we go back to the definitions again. Solid, liquid, vapor exist simultaneously in equilibrium. Does everyone get it?
Yes.
Okay, so that one is triple point. You can jot down inside the notes over here. So you label point O as the triple point. Okay, so go to the next one is our critical point. Critical point slightly difficult. So let's look at what is the explanations for critical points over here. Okay, critical point refers to a point where you have the highest temperature at which a gas can be liquefied or a gas can be condensed. So at this point, this is the highest temperature we have. Okay, so let's look at the phase diagram down below here. Which point do you think is the critical point where you can see a gas and a liquid? A, O, or B, C?
C.
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 Okay, so C is located between your liquid phase and your gas phase. So if you go back to this, the first point over here, highest temperature, okay, at which a gas can be liquefied. So that means at this point, you can still find your liquid phase. You can still find your gas phase. So this one is your critical point. Okay, so why do we say this one is a critical point? And then this point will stop here. You cannot extra plot again. So this is the last point. Dah sampai sini berhenti. Di awak tak boleh sambung lagi lah ke atas lagi ke situ sini lagi tak boleh. So sampai point C saja akan berhenti. Okay, so if you look at the second point over here, beyond this critical point, a liquid phase does not or cannot exist regardless how high the pressure you goes to. So when we say this critical point is the highest temperature, after this point, no liquid phase, no more liquid phase, no more gas phase. And we say also there is no separation between a gas and liquid, or we can also say gas and liquids coexist at the same time. Awak sampai sini, sampai point ini, okay, kita masih dapat cari liquid dengan gas phase. But beyond this point, you will no longer see any liquid phase. you are not longer see any gas phase separately. Boleh faham ke? No separations, huh?
Boleh.
Okay, so this sentence you also can repeat again lah. No separations between two of this phase or both of this phase will coexist at the same time. Okay, so I want you to further write over here. Dalam awak punya diagram awak tolong lukiskan area sini. Sekejap ya, madam adjust critical point Kita label ini sebagai critical. Okay, critical point. Okay, so beyond this point, kita letak satu area dekat sini. So this point, beyond this point C, there's no separation. Like we just now said, no separation, or both gas and liquid, they coexist at the same time. And we can call this area as a supercritical fluid. Maksudnya awak tak dapat nak bezakan antara liquid dengan phase. Or another names, this one is for extra information. This one is a supercritical fluid. Boleh catat dekat sini. Area after point C. Area after or beyond point C. Okay, so sampai sini boleh ikut.
Boleh, madam.
Okay, so we have our critical point, we have our triple point. Please recognize also the definitions over here. Okay, so let's go back to your phase diagram. We recognize one by one, yeah? If let's say I have point O, what phases actually you can find? At point O, what phase can you find?
All of them.
All of them, which refer to?
Solid, liquid, and gas.
Okay, so you fill in the blanks over here. At point O, you can find your solid, you can find your liquid, and you can find your gas or vapor phase are in equilibrium. The words are in equilibrium, that means all three phases here is coexist or exist simultaneously. How about point C? What can you find at point C?
Liquid and gas.
Liquid and gas, so we can say that liquid and gas are in equilibrium. Okay, or liquid and gas exist simultaneously, or liquid and gas coexist in equilibrium. Okay, so we want to find out along the side. Okay, so let's say I then give one more point. If let's say I have one point G over here, what is that phase?
Solid.
Solid. So any point in this area refer to solid, solid phase. How about if I got a point over here? What is that phase?
Liquid.
Okay, and how about over here? Point I. What is the phase that you have got?
Vapor.
Vapor or gas phase. Okay, but now if I give you the point situating on top of the line or on top of the curve. So let's say if you refer to curve OA. Okay, curve OA over here along the curve. So that means I have a point over here or I have a point over here. So what is the phase that you can see?
Solid and gas.
Solid and gas, because they are between both of this phase. I have my solid and also my gas or vapor phase. The solid and gas are in equilibrium. Do you get it? Is
Yes,
everyone
madam.
okay?
Yes, madam.
Okay, tell me about line OB. What phase can you find?
Solid, liquid.
Solid and liquid. Okay, so in this phase diagram, your line OB, we can find both solid and liquid phase. Or you can also say solid and liquid are in equilibrium. The last one, curve OC.
Liquid and gas.
Okay, very good. We have the phase of liquid and also the gas phase. All right, so for this one, any question you would like to ask before we proceed to the next one?
Not yet, madam.
Not yet, yeah, but it's clear, yeah, what it means by a phase diagram, a triple point, critical point. Is everyone clear over here?
All
Yes.
clear, madam.
Yeah.
Okay,
Yes,
so the
madam.
next one we want to go into is the phase diagram for carbon dioxide. Okay, you can also jot down underneath your phase diagram carbon dioxide or common substance. So that means it's the normal scenario. So carbon dioxide is one of the example that we use to represent most of the substance here. Okay, it's a normal scenario. Yeah. So if you look at this phase diagram, so you can clearly see we have a solid phase, we have a liquid phase, we have a gas phase. Of course, don't forget the y-axis and your x-axis, we have pressure against temperature. Okay, so for carbon dioxide, if you look at the standard room pressure and temperature, if you still remember the values that Madam gave you earlier, yeah, standard room temperature and pressure, it is at 25 degrees Celsius, 1 atm. So if according to this phase diagram, you can see over here, this is your 1 atm. Okay, I use a different highlighter, yeah, 1 atm along this line. Okay, and then the temperature 25 degrees Celsius over here. So you can clearly see at this temperature and pressure, we can find our carbon dioxide in the gas phase. Okay, because it's situating in the area of this gas phase. So if you have this pressure at 1 atm, you can see on the green box over here, at pressure 1 atm, phase changes from solid to gas. Okay, solid to gas or vice versa. So that means you can change over here from solid into gas or from gas into solid. Okay, so we can also say that when you want to heat your carbon dioxide solid, okay, or we know as the dry ice. Okay, solid carbon dioxide is known as your dry ice. It's heated at 1 atm. So heated, it means that you increase the temperature, isn't it? So when you heated your carbon dioxide solid, it sublimes at negative 78 degrees Celsius. So which is at this point. It changed the phase from solid straight away into gas phase. Okay, so any questions over the phase diagram for carbon dioxide? Okay, so kita teruskan untuk point yang seterusnya. Okay, so let's say if I want to ask, if I hold on a second at 5 so let's say we haven't entered the blank space on the bottom at 5.2 atm, okay, and negative 56.4 degrees Celsius, what phase can you see?
All of them. Triple point.
You can find your triple point, you can find your solid, liquid, and also gas phase.
Yes.
Okay, so at the bottom over here, you fill in your answer lah. Point O refer to the triple point. Okay, negative 56.4 degrees Celsius, 5.2 atm. So all of the phases, solid, liquid, gas phase, are in equilibrium. So dekat sini isi tempat kosong. We can find 3 of the phases there. Okay, and then over here you have your point C refer to critical point, which happens at 31 degrees Celsius. Okay, and we have 73 atm. So at this point, you can find your liquid phase and also gas phase. So beyond this point, or above this critical point, liquid phase cannot exist. Or you can also use the explanation just now. A gas cannot be liquefied, cannot be condensed, or no separation between liquid phase and gas phase. Or maybe you want to write liquid phase cannot exist. Okay, so this one you get a lot of explanations here, yeah? Okay. So next one we comes again curve OA. So just now you have mentioned curve OA. That means you can find your solid and gas phase. This is also referred to sublimation process. A dry ice sublimes into the gases carbon dioxide. So we can refer this as sublimation. Okay, sublimations, that means you change from solid into gas, or deposition process from gas into solid. So if you want to refer to carbon dioxide, you can also write the equation this way. So along the curve OA, you can find the solid carbon dioxide as well as the gases carbon dioxide. So we use the symbol equilibrium. So this symbol, it means equilibrium. That means both solid and gas phase exist at the same time. Okay, so that was referred to your curve OA. Boleh ya isi sendiri.
Madam, so tempat kosong at point O, what should we write just now?
What phase do you find at curve OA?
Curve of
Sama macam
A.
tadi. Curve OA. So tengok balik dekat sini. Curve OA refer to this line. So any point along this line, along this curve, what phase can you find?
All
Solid dengan?
three faces.
No. Along OA only. Untuk
Solid
line
and
ini,
gas.
curve ini saja. Solid and also gas. So maksudnya kalau Madam mention point ini, so maksudnya dekat line, dekat point ini, you can find your solid phase, you can find your gas phase. Triple point only situating at this one, but it intercept three of the line or the curve. Okay, kalau curve OA hanya dua phase sajalah, awak hanya ada solid dengan gas. Okay, boleh?
Boleh, madam.
Okay, so if you refer to line OB, okay, line OB is between your solid phase and also liquid phase. So if you look at the process, if you change from solid into liquid, what is that process? What is the first process for solid into liquid?
Melting.
Melting. Okay, solid into liquid. Example, your solid H2O melts into water, liquid H2O. So that is a melting process. Okay, and then if you change from liquid into solid, that is a freezing process. Ini ada chapter 5.3, the one in the app puzzle, yeah? So freezing or melting process refer to your line OB. Okay, so if you want to use the specific formula of carbon dioxide, so you have a CO2 solid in equilibrium with the liquid CO2. So right over here, fill in the blank. Solid and liquids are in equilibrium. Okay. How about curve OC? What phase would you find for curve OC? So nampak tadi I keep repeating. Tanya phase saja. So what phase could you find OC?
Liquid and gas.
Liquid and gas. Okay, so if you change from liquid phase to gas phase, it refers to your boiling process. If you change from gas into liquid, that refers to your condensation process. Okay, so fill in your blank. Liquid and gas are in equilibrium at this curve. Okay, so if you're done fill in the blanks, let's look at the phase diagram back again. So now if let's say Madam draw one lines over here, Madam guna warna lain untuk drawkan satu line. Okay, say if I draw one lines over here. Okay, and I fix my value of pressure. Let's say I have 15 atm. Okay, tell me what is this point? What do you call this point? Mada bagi hint sikit sebab dalam chapter 5.2 also mentioned about this one. So if let's say we know that the line OB refer to your melting process or your freezing process, what would you call this point? Kalau line OB faham kan untuk dia punya freezing process, melting process. If solid into liquid melting, liquid into solid is freezing. So what would you call this point? Any guess? Anyone want to try to guess?
Freezing point. Tak tahu lah.
Freezing. Ini tak ada tengok video tak? Freezing point ataupun melting
Point.
point. Okay, yang lagi senang dekat sini lah. Okay, if let's say we have the curve OC, we know this is a process either is boiling, you change from liquid into gas or condensation. Okay, if let's say I say at 15 atm, what would you call this point? The temperature when the vapor pressure is in equilibrium with the external atmospheric pressure, you still remember?
Boiling point.
Yes. So this one refer back to chapter 5.2 also lah. So it's kind of linked. It's a boiling point. But we won't say it's a condensation point. Like we only refer to boiling point or your freezing point or your melting point. Okay. But what if I draw another line over here? Okay, I draw one. My line is not according. So let's me move out a little bit into 1 atm here. Tak kena pun. Okay, say we have one line. Memang dia tak boleh tulis kat atas itu. Okay. Ataupun madam terus bulatkan dekat sini. Kalau let's say madam nak awak terangkan, dia tak akan mengena lah. Okay, tak apa, tak dapat nak lukis. Okay, but can you get the idea of this melting point, freezing point? Boleh catat atas awak punya diagram, freezing or melting point. Untuk yang ini melting point. Okay, so we proceed to the slope of this phase diagram. Okay, mana satu yang last slope yang kita nak proceed over here? If you look at this red box, we refer to the line OB. Dekat sini boleh highlight kan dalam awak punya nota, line OB. You have a positive slope. So let's look back at your phase diagram over here. If you refer to line OB, you have a positive slope. What do we say positive slope? So you can also jot down over here, line OB positive, that means slant to the right hand side. Okay, slant to the right hand side, to the right. Okay, so it refers to your melting or freezing point. So when the pressure increases, your melting or freezing point increases. So if you refer to the phase diagram over here, you can see if you getting your pressure increases from point O to point P, pressure increases going upwards. Your temperature also increases from negative 54, from 56.4, getting higher and higher. So when you refer to positive slope, it refers to melting or freezing point increases. Okay, melting or freezing point increases. And the reason is something to do with the density. Anyone want to give me the formula of density? Density equals to? What's the formula of density? Mass over
Mass over volume.
volume. So if the normal object or something like carbon dioxide, the common substance, okay, solid carbon dioxide, usually you will have a higher density because it will be denser than the liquid. Okay, so you can also refer to this formula. If you say solid carbon dioxide have a higher density or denser, what happens to the volume?
Low.
Smaller, because your solid carbon dioxide or solid substance, you will have a closely packed particles. Okay, or the particles in solid has a fixed position. Okay, they are closely packed, they're rigidly packed. So we will say the density is higher because the volume is smaller. Okay, so the reason why you have a positive slope over here, this is because your solid carbon dioxide is denser or has higher density. Okay, and at the same time, it's occupy a smaller volume compared to your liquid carbon dioxide. Okay, so if you refer to the phase diagram, at high pressure, it favors the formations of solid carbon dioxide. So if you refer over here, this sentence, at high pressure, it favors the formations of solid carbon dioxide, which has a smaller volume. So if you refer to the phase diagram here, why at high pressure, you will tend to have the solid phase rather than the liquid phase. Okay, high pressure prefers smaller volume, kind of linked to your Boyle's law. Okay, high pressure prefers smaller volume, therefore it prefers a denser solid carbon dioxide. So this one is further explanations. More heat is needed to melt the solid carbon dioxide, and therefore solid carbon dioxide will melt, and it will melt at higher temperature at higher pressure. So this one is a specific explanation. Melting or freezing point increases when the pressure increases. Solid carbon dioxide melt at high temperature, high pressure. So it all refers to the density, yeah? Okay, can fill in the blanks on your own, yeah? Denser, smaller volume. So you will see it clearly when we explain about the phase diagram for H2O. Why your H2O will, your ice will float on top of the water. Okay, sampai sini ada soalan tak?
Tak ada, madam.
Tiada, madam.
Okay, and then we go to the next one, which is our phase diagram for H2O. Okay, so H2O is different from other common substance. Okay, it's other than your carbon dioxide or any other normal substance. So H2O, you refer to your anomalous case. Your some special case. Okay, so if you refer to this phase diagram, there's one corrections for you. Please change the temperatures over here. It's not 25. This one refer to 100 degrees Celsius. Okay, so again, in the phase diagram of H2O, you have your y-axis pressure, x-axis temperature. So over here, you can see three phases, solid, liquid, and gas phase. So line OA, again, you have solid and gas phase. So yang ini dia lebih kurang sama macam tadi. Cuma kena isi balik. So if you look at this one, H2O as is a liquid at standard temperature and pressure, 25 degrees Celsius, 1 atm. So if let's say over here you do your corrections, 25 degrees Celsius, let's say we pull over here, agak-agak lebih kurang lah. Okay, so at this point, 1 atm, 25 degrees Celsius is fall into the phase of liquid. So like liquid as this as H2O as this as liquid phase at 25 degrees Celsius 1 atm. Sebab dia memang dapat dalam region inilah. Okay. So if you look at this line, focus on the pressure 1 atm. Along the line over here, you're passing three of these phases, starting from solid. Okay, pass by the boundary OB, your line OB, and then you go into the phase of liquid, and then you pass by the boundary of OC, and then you will go into the gas phase. So at this 1 atm, you actually can change your phase from solid into liquid, into gas or vapor phase, or vice versa. Kalau awak nak terbalik lah daripada kiri ke kanan ke kiri. Okay, depends your temperature. Is your temperature increases or decreases? But you can pass by three of these phases. Rather than just now when you see carbon dioxide, you can only pass by solid and gas at 1 atm. Okay, and then we can also say that your melting point or freezing point of water, H2O, so at 1 atm, this is your melting or freezing point. Okay, melting or freezing point, the point that we highlighted over here, the bigger one. You can jot down over there. So 1 atm. If let's say it's already specific 1 atm, that means this is your normal melting or normal freezing point. Tapi tak ada masalah kalau dia tak mention atm. We always refer to the normal one. Okay, and then your boiling point refer to when your pressure at 1 atm, and then it cut along the temperature at 100 degrees Celsius. So this one refer to your boiling point. So if let's say specifics already in 1 atm, that one's refer to your normal boiling point. Okay, this one can refer to your chapter 5.2 also. Kalau dia tukar pressure, let's say I want a 10 atm, that one refer to boiling point lah, tak ada perkataan normal. Tapi kalau dia sudah mention 1 atm, so that one's refer to your normal boiling point, normal melting point, or normal freezing point. So H2O is quite common, so the temperature you need to remember 0 degrees Celsius and 100 degrees Celsius. Okay, so any questions over the phase diagram in the first part here? Dah isi tempat kosong?
No, madam.
Dah jot down melting point, freezing point, boiling point. Okay, lepas tu semua benda kita akan repeat balik. Point O apa dia? So it's kind of like repeating, you need to recognize.
Triple point.
Triple point, but now the temperature and pressure change for H2O. You have 0.01 degrees Celsius and 0.006 atm. Okay, but the same thing lah, solid, liquid, and gas as is at equilibrium. That is a point O. Boleh juga lah awak nak label dekat sini. So this one refer to your triple point. Okay, so triple point. And then point C. What is your point C?
Critical point.
Critical point. So we have 374, 73 atm. Okay, so over here we have our critical point. So the notes is almost the same, yeah? How about curve OA?
Solid and gas.
Solid and gas. So if you want to write in the formulas, you can see solid H2O in equilibrium with the vapor H2O. Okay, and then for line OB is referred to freezing or melting process. We can also refer to the formula solid H2O equilibrium with liquid H2O. So the blank space you can fill in on your own. And last one over here, curve OC refers to your boiling or condensation point process. So liquid H2O equilibrium with the gases H2O. Okay, we go into the important thing. We want to refer to the slope. So can I know what is the slope refer to?
Negative.
Negative. Why is it negative?
Slant to the left.
Okay, very good. So you jot down over here, yeah, the slope is negative because it slant to the left hand side. Towards the left hand side, you can see over here towards the left. Okay, so when you say the slope is negative, it refers to when your pressure increases, your freezing and melting point decreases. Macam mana nak tengok? Kita cuba tengok. Okay, kalau kita punya pressure increases from bottom to the top, your melting or freezing point getting lesser and lesser towards the left. That means you decreasing your temperature. You're decreasing your melting and freezing point. Do you get what I mean? So mesti kena ingat kalau common substance, the normal example we use is carbon dioxide. Okay, so common substance, you will have a positive slope. So pressure increase, your melting or freezing point will increase. But then anomalous case for water, you will have a negative slope. So it refers to when you increase the pressure, your temperature for the melting and freezing point will decrease. Do you get what I mean? Did you get it?
Yes.
This is a very popular question. So when they want to ask you about comparison between phase diagram H2O and also phase diagram carbon dioxide. Okay, so let's look at the reason. Why is it negative slope? Okay, so if you come over here, we still refer to the density. We write again, density equals to mass over volume. So which density, is it liquid H2O or solid H2O, is higher?
Liquid.
Liquid. This one you can refer to your common sense. We normally will see the ice float on top of the water, right? So which one is denser? Of course, the liquid. So liquid H2O is denser because it's occupied smaller volume than the solid H2O. Of course, you can say solid H2O is less dense. Okay, this one method will refer back to you again with the hexagonal shape of our H2O. Masih ingat lagi kan? Ingat lagi tak?
Ingat rasanya.
Meda cuba lukis sikit untuk awak nak tengok balik. H2O. Kita ada lone pair, kita ada hydrogen bond. Okay. So for this one, Meda cuma lukis sikit sajalah. Okay. The structures in our ice, we have a tetrahedrally bonded hydrogen bond. If you still remember, tetrahedrally bonded hydrogen bond. Okay, we have an open hexagonal structure of this H2O, which will give a bigger volume of this solid H2O. Bigger volume, which give you a lower density or less dense. So all of this refer to your ice, or we can also say the solid H2O. Or maybe you want to use the symbol H2O in solid. So remember, tetrahedrally bonded hydrogen bond, we have an open hexagon shape structure, or the shape. It gives you a bigger volume, which in turn give you a lower density. Okay, a lower density. So ice less dense. So that one's refer back again. And over here, why Madam put a denser liquid? Now we refer to the diagram. Easier for you to remember. You can either choose the ice or the liquid to explain. No problems one. Okay, I use a highlighter to see. When the pressure increases, you prefer a smaller volume, isn't it? Pressure increase, prefer a smaller volume. So if you look over here, if you increase the pressure, we prefer to have a liquid. Okay, we prefer to have a liquid which have a higher density, smaller volume. So three of this point is linked. High pressure, smaller volume, higher density. Okay, so if let's say we compare back to our phase diagram for carbon dioxide. Okay, again, high pressure prefer smaller volume, which will refer to a solid carbon dioxide which is denser. So please look at the difference for both of this phase diagram. Kenapa kita prefer liquid? Sebab liquid punya density is higher and then it has a smaller volume. So this is the keywords. If you want, you can highlight over here. Ataupun awak boleh jelaskan density of solid is lesser and it has a bigger volume. Boleh vice versa, tak ada masalah. But if you feel confused, you can follow the explanations method given. Okay, so we say that at high pressure, it favors the formations of liquid H2O, which has a smaller volume. High pressure prefer smaller volume, and smaller volume give you higher density. So 3 point ini adalah link. Okay, so less heat is needed to melt the solid H2O, and we can also say ice will melt at lower temperature at high pressure. Okay, because of this negative slope, if you increase the pressure, you will get a smaller melting point. Okay. So for this negative slope, is there any question you would like to ask the anomalous case for H2O? Ada soalan tak ada?
Tak ada.
Okay. If no questions, we see a more complete comparison between the carbon dioxide and also H2O phase diagram. Okay, so over here we have the carbon dioxide for phase diagram A. We have the phase diagram for H2O. Carbon dioxide is the common one. Okay, H2O is the anomalous. Okay, so you can see over here we have a positive slope for carbon dioxide. We have a negative slope for the water, for the H2O. And then the summary also returns over there if you refer to CO2, because the solid is denser, therefore it will prefer, okay, to have a smaller volume, higher density of the solid carbon dioxide. But in compared to H2O, liquid is denser, or the liquid H2O is denser, therefore it has a negative slope. So the comparison is clearly written over here. Positive slope, pressure increase, melting point or freezing point increase. Solids is denser. It favors the formations of solid. And the examples given is for carbon dioxide. So the negative slope refer to the water. The common example is water. Increasing the pressure will decrease the melting point or freezing point. Liquid is denser. It favors the formations of liquid. Okay, so this one is for your reference lah, for you to identify the differences between both of these phase diagram. Okay. So we go into our next part, which is the phase changes. So this one also you need to write out something. Phase changes, it refers to how do you change your phase from solid into liquid or from gas into liquid or whatsoever. So you need to look at the condition. So remember just now in our learning outcome, we have mentioned we want to know about the phase changes for the, if we adjusting the temperature at constant pressure or adjusting the pressure at constant temperature. So dekat sini Meda ada bagi boleh highlight kan. Meda bagi berapa contoh sajalah. Okay. So let's see the first one. If we adjust temperature, that means either we increase the temperature or we decrease the temperature. But we need to keep the pressure constant. Okay. Another way of saying at constant pressure, we can say it is at isobaric condition. Okay, perkataan isobaric is come from bar. Bar is one of the unit of pressure. So it's at constant pressure, isobaric. So if let's say, if you look at the first example, from point A, this is our point A. Okay, we increase the temperature isobarically. So it refers to you increase the temperature at constant pressure. So phase changes from, kita tengok dulu daripada point A sampai sini adalah awak punya boundary. Okay, so from solid, we start from solid. So you will go into the boundary. At this boundary, what do you see? What phase do you see? What phase will you see over this line?
Liquid.
Sebelum liquid?
Solid.
Sebab kita akan langgar phase ini dulu. Kita akan langgar tiang ini dulu kan? So tiang ini ada apa?
Solid and liquid.
Solid and liquid. So that means bila awak langgar tiang, awak kena ada phase itu. So over here, this cross, when you cut along the boundary, you have solid and liquid in equilibrium. Okay, so pay attention to how I'm writing the phase changes. Solid starting from your point A. Okay, and then it touch the line. You touch your line OB kan, tadi ada line OB. Okay, at this point, you will see your solid and liquid in equilibrium. So when it is in equilibrium, please also put the bracket. So that means you will see this is the same at the same point. So you have solid and liquid in equilibrium. I'm using the sign. Please focus on the arrow. So this is the arrow of equilibrium. Okay, lepas tu kita teruskan. Okay, over here we go on to the next stop point. So at this point, what do you have?
Liquid.
Liquid. Okay, so dekat sini kita tulis lah. Okay, we have the liquid phase. And then we proceed again. So langkah satu tiang lagi. Tiang ini ada apa?
Liquid and gas.
Liquid and gas. And remember, we need to have a bracket. Liquid and gas in equilibrium. Okay, and then we continue our journey to our last point over here. What do you have at that point? Last point ada apa? Ada phase apa?
Gas.
Gas. Okay. So this is your answer then. Your phase changes starting from point A, you have solid, into solid and liquid in equilibrium, into liquid, to liquid and gas in equilibrium, to gas. Missing one more arrow ya. Dekat sini kena ada satu laluan. Into gas phase. So this is when you increase the temperature at constant pressure, isobaric. Okay, so kita try satu lagi, point C. So let me change one more color. Okay, so point C starting from here. This is a point C. So if we reduce the temperature isobarically or reduce the temperature at constant pressure, so that means this is your constant pressure. Berlaku kat sini saja daripada point C. Okay, from the right hand side towards your left hand side. So what is your start point? What is the phase of your starting point?
Gas.
Gas phase. And then you're going into the boundary, which is what phase do you have?
Gas and solid.
Yes, very good. Gas and solid in equilibrium. Gas and solid in equilibrium. If you want to write solid and gas, solid first and then gas, no problem, yeah? But you need to recognize lah what phase do you have at that point. Okay, and then we towards the next one, which is what point? At the last point over here, from the right hand side to the left hand side. Sebab dia reduce temperature again.
Solid.
So last point over here, we have solid. So from gas into gas and solid in equilibrium to solid. So is any questions on the phase changes for the first part, isobaric? Ada soalan tak? Tak ada. Okay, accept mah? Boleh faham ya? Okay. Then the second condition is if you adjust the pressure, okay, at constant temperature. Yang tadi kalau constant pressure, you look at this line. Dia dekat satu line saja, satu pressure. Let's say I keep this one as 1 atm. So semua berlaku pada 1 atm. That is constant pressure. Okay, if I constant at this line only. So let's say this one is 0.5. So I keep the pressure at 0.5 atm only. But if I want to make it at constant temperature or isothermal, I need to make it at the same temperature. So let's say over here, same temperature starting from point B. So dekat sini saja kita tengok lah. So let's say over here is 30 degrees Celsius, example. So we look at 30 degrees Celsius only, but the pressure will change. Okay, so if for the first example given, from point B, reduce the pressure isothermally or reduce the pressure at constant temperature. So reduce pressure dari atas ke bawah ke dari bawah ke atas? What do you reckon? From the top to the bottom or from the bottom to the top? Reduce the pressure.
Top to bottom.
Sorry?
From the top to bottom.
Okay, so from the top to the bottom, so starting from your point B, going towards the points over here. So what is the phase that you start? Point B phase apa?
Liquid.
Liquid.
Liquid. Okay, so into what phase? Langgar tiang dulu kan?
Liquid and
Liquid and
gas.
gas.
Okay, liquid and gas in equilibrium. Okay, so please pay attention to the arrows that I'm using, and then I cross the bracket, and then after that, towards the last point, you will see
Gas.
gas phase. So this is the phase changes. Always write from the left to the right, daripada kanan, daripada kiri ke kanan. Tapi yang condition, you have to look at the questions. Okay, so let's say if I change another scenario from so let's say madam buat satu lagi point baru dekat sini. Okay, let's say this one is my point G. Okay, so if I increase the pressure isothermally, it happens at 10 degrees Celsius. Let me know about the phase changes. Let's say I want to increase pressure isothermally. So what will be its point changes?
From gas.
Gas.
Okay,
to
starting
gas
from
solid.
gas into?
Gas solid.
Okay, very good. Sebab awal langkah tiang, gas solid in equilibrium into?
Solid.
Into solid. Okay, so there is our phase changes if I want to increase the pressure isothermally. So I can either use at constant pressure isobaric or at constant temperature isothermal. Is everyone good? Boleh ikut?
Boleh.
Ada soalan tak? Tak ada. Senang? Susah? Okay ya. Right. So let's just try a few questions over here. Soalan pertama, given the temperature pressure for water and its triple point, critical point, you need to sketch the phase diagram. Based on the phase diagram, explain how melting point of water changes with increasing pressure. So this one, I'll leave it to you. You just need to sketch the phase diagram. But don't worry, I will show you another example using question number 3. Okay, I'll show you how to sketch the phase diagram. But first questions over here, I want to ask, what is the slope? Okay, the slope, is it positive or negative for the phase diagram of water?
Negative.
Negative.
Negative. So if you already know this is the phase diagram for water, you must make sure you have a negative slope in the diagram. Okay, you must make sure there's a negative slope sebab awak sudah tahu dia adalah water. Kalau dia bagi tahu carbon dioxide, so awak bagilah positive slope. Okay. So we try to sketch one phase diagrams using this example. You can sketch together with me using a piece of paper or straight away down below the questions lah over here. Kita sketch sama-sama ya. Okay, so given in the questions, we have substance X has a triple point. Let us highlight substance X. So we have no idea whether it is a common substance like carbon dioxide or the anomalous H2O. No idea, right? So we have to sketch one by one. Okay, so you have a triple point, which is at 80 degrees Celsius, 0.5 atm. And then they give you melting point at 20 degrees Celsius. Okay, and then we have a boiling point at 300 degrees Celsius. So sketch the phase diagram of X. First thing first, what is my y-axis? What is my y-axis?
Pressure.
Pressure.
Pressure. Okay, so pressure, the usual, we have ATM lah because they give you in ATM. How about your x-axis?
Temperature.
Temperature. Okay, what is the unit?
Degree Celsius.
Degree Celsius. Thank you. Okay, so where should we start first? Kat mana kita nak mula? Kita ada informasi apa?
Triple point.
Triple point.
Triple point. So let's say I put over here, I have 1 point over here, which is my 80 degrees Celsius. I have, Medan tak ikut scale sebab ini sketching, we just roughly sketch only. Okay, so 0.5 atm. So this one is your triple point. Okay, so phase diagram, actually you don't have to worry. As long as you can see solid, liquid, gas phase, you can label the points given, then the overall phase diagram will look more or less the same. So let's say we know already our triple point, right? So we have our curve OA, if you still remember what we did just now. You don't have to begin with the origin. From the middle also can. You want to sketch from here also. You want to sketch from here also can. No problem. You want to sketch from the middle also can. Okay. And then what's the next step that I can do? What is another information I have?
Melting and boiling.
Melting point. So if you still remember, if the question doesn't mention the pressure of the melting point or boiling point, it occur at which ATM? At what ATM?
1.
1.
One.
And soalan tak mention, we have to recognize this one happens at 1 ATM. So let me put over here my 1.0 ATM. And I just plotted lah, dot, so that I can see where should I plot my melting point. Okay, so melting points are 20 degrees Celsius. I have already got the 18 over here. So on the right or on the left, I should plot. Towards the right or towards the left? Kalau 20, kat mana dia?
Towards to the right.
Towards the right. So let me put over here, I have 20 degrees Celsius close by to 18 because it's quite near, right? So at this point is my melting point. So saya letak 1 point. So nampak tak dia ialah positive slope ke negative slope?
Positive.
Positive.
Very good. So over here, I can see a positive slope. If you still remember just now, we get the point O, we got the point A, this is your curve OA, this is your line OB. So senang sikit untuk awak nak nampak. So line OB, positive slope. Okay, how about the next information I have got?
Boiling point.
Boiling point, it occurred at 180 M, which is 300 degrees Celsius. So saya lebih kurang lah plot dekat sini sebab 300 is quite high, right? So let me plot over here. We have 300 degrees Celsius at 180 M, and I just roughly sketch it. Okay, so this is my phase diagram, but remember I need to label. Jangan tinggalkan awak punya phase diagram. Apa information yang ada kita plot dulu. Okay, so just now we have this triple point. So let me use a different color, yeah. So this is my triple point. Okay, and then I label this one is my melting point, right? So I write down, I label melting point. Okay, this one is my boiling point. What else can I label?
Phase.
So besides, sorry?
Phase.
Phase. What phase do I have? Over here? Over this region, what phase do I have? The first
Solid.
region over here, solid. You cannot just put symbol lah, must write solid. Kalau awak letak S, L, G tak boleh diterima mesti penuh solid. And then after that, we have over here is our liquid. And how about the next one? The last phase over here we have got
Gas.
gas, or if you label vapor, accepted. I think one more is missing. What else we can label?
Critical point boleh ke?
Kat mana kita nak letak critical point?
Atas sekali dekat line liquid dengan gas tu.
Okay, last sekali. Make sure you label. Kalau awak terlepas ada satu sikit line lagi, tidak boleh diterima sebab critical point is the highest pressure that we can find liquid and gas. Okay, so over here you can label your critical point. Make sure over this point there is no more line. Okay, so here you go. You have a phase diagrams sketching from scratch. So that means you sketch according to the points given, according to the informations given. So this is the phase diagrams of your substance X. Boleh teka tak substance X ialah apa? Cuba bagi example. 2 example saja kan? Yeah. Okay, so either CO2 or any other common substance. Okay? So for the first one just now, question number 1 is already given water, but you just need to label triple point and critical points only. Okay, let's just look a little bit more on question number 2. We have a phase diagram for substance P. Okay. And question A, determine the point at which substance P exists in vapor phase. Nanti nak awak tambah satu lagi ni ada satu simbol H dekat line atas point B. Okay, so first one, determine the point at which substance P exists. So what is the point exists as vapor phase?
Point E.
Point E, very good. So yang ini kenapa lompat keluar? Hold on. Okay, so point E. How about the second one? Exists in equilibrium with solid liquid phase.
Point B.
B.
Point B, where you have the solid and the liquid. If you can't recognize, it will be good that you can label it before you start answering. So we have solid, liquid, and gas phase. How about A3, in equilibrium with solid, liquid, vapor phase? Which point?
G.
And it is called as
Triple point.
triple point. Yang lain boleh ikut Madam bincang jawapan ni terus. Bagi tips sikit Okay. So is everyone good for part A?
Yes.
Okay. Okay kan? Untuk soalan B, Madam nak pilih orang untuk jawab. Okay, let me see who is here. Banyak nama yang Madam tak pernah panggil kan? Alright, can I have Nazmi? Is Nazmi over here? Tak ingat kelas pula. Nazmi. Nazmi. Tak ada. Nanti Madam terus kira attendance kosong. Tak ada orang start left
I reckon their internet connection is slow because just now even I had to catch up a bit.
Oh, okay. Tak apa, kita pilih seorang lagi. Fatin, Syafiqah. Ada tak? Fatin, Syafiqah. Dia respon. Dia ada catat nama. Siapa lagi? Azza. No Azza. Azza. Is Azza over here?
Yes, madam.
Ya, bagus. Okay. So, Azza, ready ya? We go to the next question. State the phase changes that occur when substance P at point C is heated at constant pressure. Point C is heated at constant pressure. So, what answer would you give me? It's heated. That means temperature is increasing, right? So, for point C, what's your phase changes?
Liquid.
Okay, very good. We start from liquid into
Liquid and gas.
liquid and gas because you come across the border, right? So liquid and gas in equilibrium. Lagi?
To gas.
To gas. Tak ada lagi kan sampai point E sini. Okay, very good. Thank you, Azza. Okay, we have another one, point A. So can I have Zarif Irfan?
Ya, madam.
Yeah, boleh bagi tahu madam kalau point A depressurized, that means we reduce the pressure at constant temperature. Point A kat mana? Point A kat sini. So what will be your phase changes?
Solid.
Solid. Tu.
Dia kata dia buang apa ni, buang haba madam kan? Madam.
Apa ni buang haba?
Dia depressurize tu maksudnya dia tak serap haba kan?
Kurangkan pressure. Bukan tak serap haba, dia kurangkan pressure, depressurize, decrease the pressure. So madam sudah tulis arrow dah. So macam mana? Solid per? Solid?
Solid.
Apa yang kita? Solid.
Solid liquid. Okay.
Bawah sini area ni semua adalah gas. So solid and
solid to gas.
solid and gas in equilibrium.
Betul.
Sebab dia langkah tiang. Ini tiang dia. Langkah dia akan masuk phase equilibrium dulu. So solid into solid and gas in equilibrium. And then last one into
Gas.
gas. So make sure everyone know how to draw the phase changes. Okay, last one. Nasha. Is Nasha over here? Nasha Dawina. Nama
Madam.
cantik. Orang pun mesti cantik. Ya, Nasha. Okay. Name the point at which line GH intersect 1 ATM. What is the name of the point when you have the line GH, this line, intersect at 1 ATM, which means it's your point B. So what do you call this point? Ada clue tak? Ada highlightkan clue untuk awak ya?
Freezing point.
Okay. Ada highlightkan 1 ATM. So in front of freezing point, what should you put in? Come on. 1 ATM. You start with N.
Point.
Huh?
Boiling point.
Boiling?
Point.
Boiling point pula. Solid to liquid, it refers to melting or freezing process, right? So either melting point or freezing point. Tapi soalan sudah mention 1 ATM. So in front of that melting point or freezing point, what should you put? Any others want to help? Any others want to help? What do you put in front of that melting or freezing point? Tak ada orang tahu.
Normal.
Yalah, normal. Mana dah highlight ke 1 ATM. So at this point memang dia sudah fixkan pressure 1 ATM. So you put the words normal. Unless the question doesn't give you pressure, then we will assume it is normal melting point, normal freezing point, or normal boiling point. So tak kisahlah awak letak melting or freezing, that's okay. Sebab memang line itu adalah melting or freezing process. So is everyone good?
Yes.
Boleh ya? Okay, nota refer balik lah. Phase diagram punya nota. So hari ni tak ada kerja lah. Cuma soalan satu kena practice plot the graph. Today no homework. As I want to give space for you to do your revision. What do we have tomorrow?
Practical.
Esok ada apa?
Practical test.
Oh,
Practical
tomorrow
test.
is the one that we need to print out the question, isn't it?
No, Hazim. Esok adalah Google Form dulu. Hari Sabtu baru print out.
Alright. Because the
Okay.
one that we need to print is the worst nightmare because anything can happen. So, when will it be?
Tomorrow, you refer to the message that Madam bagi. Tolong jot down. This week you have a lot of tests. Please be present. But okay, try to stand by earlier. Okay, try to stand by earlier. And then tomorrow we have the practical test. On Tuesday we have our UPS 2. And then on the Saturday we will have our practical test, the lab report writing.
On what did? Hold on. Tuesday. What did we do again? I'm sorry.
Azim, tengok balik message. Hai, Madam tengok message. Tengok balik message.
Oh, you already sent. Okay.
Cari balik dalam message. Dah. Ada kat sini ada.
Madam,
Bukan sini. Dah. Ya.
so kita orang tak ada buat practical test dekat lab lah, dekat nanti masuk KMJ nanti. Kan?
You sudah balik
Tak. Saya tanya. Tak apa, Madam. Saya tanya sebab
practical test Practical test lah. Practical test awak cari kalau sesiapa yang sudah ada dalam college. Madam, stop recording first. Wait. Hold on. Wait. Yo jangan keluar dulu. Madam bagi info ni. Hold on nak.